All right, so today we're going to take a look at the rest of section 10.3. And 10.3 was about two different topics. They were about permutations, and in permutations, the order or the arrangement or how something is done, the order in which it's done or the arrangement of how something is done matters. And then in combinations, it doesn't. You're just selecting a group of something, and it doesn't matter who gets picked first or last or who's sitting in the first seat or the last seat or any of that. You got to get on the bus, okay? That's what a combination is. So the one I wanted us to take a look at today, there's one problem left, but we're going to do, 6 or 7 parts to it. And it's all this problem number 5. And problem number 5 says, consider a 5-card poker hand and find out how many blank. So we're going to find out how many of the following things happen. And as we're going to take a look at this first, I want to go through, because some of you are probably not as familiar with cards or decks of cards as others. So that everybody's on the same playing field, and we're all talking and know what we're talking about in the same thing, we're going to go through some of the details of a deck of cards. Okay? If you want to jot some of these down or not, it doesn't matter to me, but whatever you need to sort of write down to remind yourself of these facts, please do. So, first thing is, how many cards are in a standard deck of cards? There are 52. There's 2 colors. What are they? Red and black. How many? What's that? How many reds are there? 26. So how many blacks are there? 26. Okay, good. That's good, right? Because that's going to make up my 52. We're not playing with jokers, so if you know what jokers are, you can ignore them. We're just using the cards that you typically play with games. And how many suits are there? There are 4 suits. What are they? Hearts and diamonds. Let's pause for a second. Hearts and diamonds are both red. And then the other 2 are what? Spades and clubs, and those are both black. So how many of each suit are there? 13. So there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Okay, everybody good so far? All right. What are the values on the cards?
2 through ace.
2 through ace. Okay, so 2 through 10 are my number cards, right? So how many number cards are there in each suit? Let's say it that way. In each suit. 9. Ace is not a number card. We're going to talk about ace, but he's not a number. Yeah, we'll get back to him. All right, so the number cards themselves go from 2 to 10, so there's 9 of them in each suit. So there's 9 of those in the clubs, and there's 9 in the hearts, and 9 in spades, and 9 in diamonds. So how many number cards are there? 36. There are 36 number cards. Okay. How many 7s are there? There are 4 of them, right? So each value of a card occurs exactly 4 times, once in each suit. Right? Okay. Besides values that are numbers, we have aces, that Clinton mentioned. And so ace is either understood to be a low card or a high card. We're not going to talk about that in that sense, but sometimes we kind of understand it to be the low card as a number 1 when you're playing some games. Sometimes it's considered to be the high card and it trumps everything else. And sometimes you get to pick. It depends on the game you're working with. So that's aces. What else do we have besides aces? And we got one of those in each suit. King, jacks, and queens. Okay, so my face cards are the kings, jacks, and queens. Ace doesn't usually get counted either as a face card or as a number card, at least not in the way your book's going to approach it. Okay, so if it talks about number cards, it really means it has a number on it. And if it talks about faces, I wish I had a deck of cards to show you, it really means it has a face on it. Okay, like literally, like face. Okay, so a face on there, and those would be the kings, queens, and jacks, right? So there's 3 face cards in each suit, and there's 4 suits, so how many face cards are there? 12. Okay, so let's start in with this problem now. We've got to basically hit on some of the highlights, and I think we've hit on just about everything we need for the problem, and if that's not the case, we'll mention it again as we keep going, but I think so. All right, so the first thing we're asked to find out is how many hands there are, how many 5-card hands there are. Now, before we get too much further into this, you have to remember what was the title of this section?
Using permutations and combinations.
Okay, so the first thing I have to do is to what?
Find a permutation.
Decide if it's a permutation or a combination. So what do you think?
Combination.
It's a combination. Why?
Because it's not just order, just how many hands.
Yeah, as a matter of fact, when you are dealt a hand of cards, what's the first thing you usually do?
Look at them.
You order them, in whatever game it is, right? I don't care if it's Uno or Slapjack or War, Old Maid. The first thing you do is put in some kind of an order that you want it to be in, right? So it doesn't matter whether you were given an ace first or an ace last. As long as an ace is in your hand, you've got an ace in your hand. So the order doesn't matter. So on every single part of this problem, we're going to be using combinations. Okay, is everybody clear on that? So anytime we're dealing with this deck of cards, we're talking a combination problem. So we're going to see C's everything we do today. C on everything. All right. Question number 1 then says, how many 5-card hands do I have? So I'm going to do a combination because I'm starting to write. That's why it happened, don't you think? It was working perfectly until then. Oh, dear. All right. Am I online up there? Can you see me? Okay. The C goes here. What number goes in front of C? 52. The number that goes in front, whether it's a combination or a permutation, is how many things you're picking from. And how many are we picking from here? 52. There are 52 cards that I'm being dealt from, right? Whoever the dealer is, whether it's me or someone else, had a stack of 52 cards, then I get 5 of them. So there's a 52. Okay, let's try that again. Thank you. There's a 52 in front of the C. Okay, and then the number that comes after the C for you guys over here, would be the number I'm picking. In this case, that would be 5. I've got a 5-card hand. Okay, so now it's time to see what you remember from the notation for combinations, or you can flip back to tell me. What goes on top?
52.
Good. 52 factorial. You bet. Now what? What goes on bottom?
5.
Okay, and just as a reminder, where'd the 47 come from? 52 minus 5. Okay? So for combination, the number that I'm picking from my can of cards in this case, the 5 factorial is in the denominator, and then the other number that's in the denominator is what I would have been picking from, 52, minus the number I picked, 5. So 47. Okay, what am I going to do next?
Stop 52 to 47.
All right, so I'm going to write 52, 51, 50, 49, 48, and 47 factorial. Please don't stop at the 47. It needs a factorial on there. What's going to go in the denominator? Okay.
5, 4, 2.
Right. 5, 4, 3, 2, 1.
And then 47 factorial.
And then 47 factorial. What's going to reduce first? Absolutely. Get rid of the 47 factorial. Now we have choices, and sometimes you have more choices than others, but you always have some amount of choice. What would you like to pick, and what would you like to reduce?
5 and 50.
All right, 5 and 50. So the 5 and the 50 makes the 50 become a 10. Now what?
4 and 48.
All right, 4 and 48. And what will the 48 become, Alice? It'll become
Oh, no, 12.
12. Good. Remember, it's division. Right, 12. Now what?
3 and 51.
You can do 3 and 51, or you could do 3 and 12, right? The 12 that you just got from a minute ago there, Alice? You could do that too. You mentioned the 51, so we'll do the 51. 3 and 51, what would the 51 become? It is 17, kind of an odd number there, prime in fact. And then how about that 2? It's got a couple choices. You can do 2 and 52. It's actually got 3 choices. What will the 52 become? 26. Now, we talked about this last time. Be really careful. Don't lose any of these pieces along the way. I've circled them. I'll also rewrite them just to make sure everybody's on the same page. I have a 26, 17, 10, 49, and 12 that I'm supposed to be multiplying. You don't have to list them all out, but just be really careful that you don't lose track of them in your work. What is that?
2,598,960.
Yes, it is. So there are over 2.5 million different cards, 5-card hands of cards. When you take a 52-card deck and you deal out 5 cards, you could do that 2,598,960 times and never repeat the exact same 5 cards. That's kind of crazy, right? That's a lot of different possibilities. Now what we're going to do is we're going to start limiting the different possibilities and see just exactly how much that limits the number of hands that happen. So the second one is a hand of all red cards. Now, that doesn't do you any good in most games. But I want you to understand that simply taking half the deck and removing it, sort of, right? We're not going to use the black cards in this one. I want you to see how that changes the number of cards that you have, number of hands of cards you have. So we already discussed from a minute ago that this is going to be a combination, correct?
Correct.
How many am I picking from?
Very 26.
It's 26. Why is it 26 this time?
Because we still have the black card.
Because we don't want the black cards. We want to only pick red cards. So there's 26 different red cards I could get, and I want 5 of them, right? Okay, everybody good with that so far? What goes on top?
26.
And what goes on bottom? Right. Good. 5 factorial, 21 factorial. Okay, so I'm going to write that 26 out until I get to what? 21. So 26, 25, 24, 23, 22, and 21 factorial, with a 21 factorial on bottom. And my 5s are going to do just like last time, right, Alice?
Yeah.
What you did before for me?
5, 4, 3, 2.
Thank you. 5, 4, 3, 2, 1. All right, what am I going to cancel first?
21.
Yeah, I mean, I'd cancel the 21 factorial first. But then, Mackenzie, what do you want to cancel second? Sure, 5 and 25, and the 25 will become a 5.
26.
Oh,
Or 24.
24 and 4, and what will the 24 become?
6.
A 6. Now what?
2 and 26.
Okay,
22.
do you want to do 2 and 22? It is. So the 22 will become a 11. Okay, I need to cancel one more number. 3 and 6. And the 6 will become a 2. Now I've canceled a bunch of stuff. So here's 26, 5, 2, 23, and 11. What does that give me? Say it louder for me. No?
65,780.
Okay, do I have a second on that? Is that what you have two? Okay, we got 2 people with that answer. Now, I'm not going to argue that 65,000 isn't a lot, but 65,000 is a whole lot less than 2.5 million, right? I mean, it's not like we just cut it in half. When we took out half those cards and we drastically reduced the number of cards that we could have that look like this in my hand. Number of hands of cards that look like this, right? We're going to do it one more time. This time, what are we going to do? Hands of all hearts. Okay, so how many hearts are there?
13.
There are 13. We've already talked about this being a combination. And how many am I going to pick? 5. Now, do you know what it's called when you have a hand that's all one suit?
Flush.
It is a flush. So this would be a heart flush. This is not going to be the number of flushes in a deck, but this will be the number of heart flushes in a deck. Okay, for those of you who are familiar with that lingo, and I promise I won't use that lingo on a test, but I just want you to be aware of it, so if you've heard of it, you'll know what they're talking about. All right, hands of all hearts. What's going to go on top? 13 factorial. How about on bottom? 5 factorial and 8 factorial. So I'm going to write my 13 out to what? 8. So 13, 12, 11, 10, 9, and 8 factorial. Over my 8 factorial. What else is going to go down there? 5, 4, 3, 2, 1. What's going to cancel?
4 and 3. 12.
Okay, you want to do the 4 and the 3 to the 12 like that? Okay, somebody else tell me something. The 8 factorials. 5 and 2 are 10. Sure. This one actually paired up into some nice values. And I end up with a 13, 11, and 9. What is 13 times 11 times 9? 1,000. What was next? 287. Got a couple of you? Again, I mean, if you want to give me 1,287 as long as it's not a bribe, I would take this money. But that's considerably less than 65,000, right? I mean, like, hugely less. So all I did is I took away half the cards, and the number of cards, number of hands of cards of that type just hugely got slashed. I end up with only 1,287 instead of 65,780. All right, let's do something where it combines something. Well, we got one more before that. How about hands of all jacks? Okay, so 4C5. What's that? No, say that louder, Mackenzie.
It'll give you a negative number when you subtract.
Okay, so if I try to use this formula, it's going to give me a negative number somewhere in there with the factorial stuff. And we didn't have a definition for what happened with the negative factorials, right? There was nothing in there. It all had values bigger than 0. Well, 0 or bigger. So why is that happening?
Less options.
Because you only have 4 cards when you fly.
Yeah, I've got 2 people saying it now. So I'm going to let Stephanie tell it really loud for us. Can you tell us again?
Because you only have 4 cards when you fly.
Right. There are only 4 jacks, correct? So how in the world am I going to get 5 jacks when there are only 4 that exist? I'm not. Right? This is not possible. So how many hands of all jacks are there? That would be 0. If you do have one, then you've probably got either some decks mixed up or something far worse like cheating going on, right? Not good. Yes, this cannot happen if you've only got the 52 cards. Okay, so let's change it slightly so that it makes more sense for Part E. Part E actually says that I want a hand of 4 jacks and then something else. Okay? Now, the first thing to recognize is that we have to do these 2 parts separately. First, I've got to figure out how I get my hand with 4 jacks. And then, second, after that, I'm going to figure out how I get 1 extra card. Okay, so we're just looking at the first half of this argument right now. How do I select a hand that's got 4 jacks in it? That is 4C4. Okay, everybody good with that so far? So that gets me all 4 jacks in my hand. Now I need to pick 1 other card. How do I do that? Do you have it, Tyler? Do you know? 48. So where'd you get 48 from? Right. So there's 52 cards in a deck, and you took out 4 because those were your 4 jacks, right? So we've removed the 4 jacks. We don't have 52 cards anymore. We've only got 48. How many do we need to pick? 1. And this is like what we did back in section 10.2. What you're doing is you're actually taking the way you get the first 4 cards, okay, kind of like when we were doing those fundamental principles of counting where I did 4 lines, right? Here's my first 4 cards. That's my first 4 lines kind of written in. And this is my last line, and I'm going to multiply these things together. Okay, do you remember that? Like the class schedules and things that we did with the different problems in 10.2. So this is multiplication. Okay, so let's do the 4C4 first. How do I write 4C4? What's it going to be? 4 factorial over 4 factorial and 0 factorial. And this is, in fact, the reason why we need a definition for what 0 factorial is. And it's 1. Okay? So we'll deal with this in just a sec, but this is 1. Okay? Now let's do the 48C1. How's that one going to look? 48 factorial. Over 1 factorial, 47 factorial. Okay, so if you want to move your work going straight down from there, I have to go sideways because I'm out of space. But you can move straight down from here and keep going. What does this first piece become? What is 4 factorial over 4 factorial? This is just 1. And think about this. This should make sense. There are 4 cards, and I want all 4 of them. And if I don't care what order I pick them in, there's only one way that can happen, right? And I don't care because this is a combination. How about the second one? What happens when I have 48 factorial over 47 factorial? It's 48, right? Because I actually could write it out. I'll write it out so you can see it. But it'd be 48 times 47 factorial. And then the 47 factorial on the denominator would reduce, right? So all of this works out to what number? 48. There are only 48 hands of cards that would have 4 jacks in them. So this is pretty uncommon, right? Now let's expand the image just a little bit further with the next one. Instead of it just being the 4 hands of jacks, I want a hand that's 4 of a kind. What does that mean? Not quite.
13
Okay, there's 13 of what?
options.
There are 13 options that I could pick my 4 of a kind from. Is everybody with me on that? So I could have 4 jacks, or I could have 4 threes, or I could have 4 aces. I've just got 4 of some card. Does that make sense? Okay. So the first thing I need to do is I need to figure out how many choices of cards I have, and you told me before, Tyler, that it was 13, right? Okay, so the first thing I'm going to do, and I'm going to write out why I've done each of these pieces when I'm done so that you can kind of get a sense for that, is I have to pick which of the cards is going to be the 4 of a kind. And once I pick out of the 13, I need to pick all 4 of them. So this chooses the card. Let's say value. Let's choose the value. That is, it chooses that it's an ace, or it chooses that it's a 3, or it chooses that it's a 10, or whatever. And this chooses all of those value. Okay, but how many cards do I have in my hand now? No.
Oh,
I only have 4. The first one, the 13C1, didn't pick an actual card. It just picked what value I'm going to be working with. It didn't actually pick an actual card. The 4C4 picked all 4 of those cards. But I only have 4 cards in my hand right now. I still need how many more? 1 more. How many more do I have to pick from? 48, just like last time, right? I have 48 cards. And I'm going to choose one of them. All right. Now, fairly soon you'll get to a point where you know what this number is. Some of you may be already here, but I'm going to do it one. Yeah, Alice knows. I'm going to do it one more time because I've only shown it once, and then we're going to establish the fact that we know this fact now. So when I see the 13C1, I know I have 13 factorial over 1 factorial, 12 factorial, right? And I know the 4C4. What does the 4C4 end up being? Yeah, 1. I already did that on the previous slide, so I'm not going to redo that. And I know what the 48C1 is because I already did that on the previous slide too. That was 48. Okay? What does the 13 factorial over the 12 factorial become? That's 13. So this is actually 13 times 1 times 48. Now, in the event that you confuse what I'm saying, this is not a good plan to think about, but if you can keep straight the fact that everything I'm telling you is about combinations, it will work. When you're dealing with a combination, if you have the number the same like this, 4C4, 5C5, 10C10, that's always 1. Okay, if the number matches before and afterwards and we're dealing with a combination, that's a 1. Okay? And again, with a combination, if the number at the beginning and then having the number at the end is a 1, right? We did the 13C1 here. We did the 48C1 here. What does it become?
the number at the beginning.
Just the number at the beginning. Okay, again, that's a combinations feature. Okay, so don't try and apply these things with permutations. Permutations do act a little differently. But this is a feature that we could use. So somebody's going to tell me, what is 13 times 48? 624. Okay, so pause with me for a moment and compare. I had a discussion a number of years ago with a brother-in-law. My brother-in-law is a very capable contractor. He's a wonderful firefighter, not so good with math. We had a discussion about poker, but it was about the statistics like what we're looking at with poker, and he was fully convinced that it was far more common to get a 4 of a kind hand than it was to get a flush hand. How many 4 of a kind hands are there?
624.
There are 624. How many hands of all hearts, that is a heart flush, are there?
1287.
1287, and that's just hearts, right? I'd have 1287 that would be spades flush and 1287 diamonds. I'd take this number times 4. Which one's more likely?
Flush.
A flush is more likely. So if I have a flush and Sabra has a 4 of a kind, who wins? She does, because it's less common. That's how they make the decisions with poker, is how common something is. Okay? So the 4 of a kind is less common, so that would win. Whenever you watch, if you're on the Poker Channel, whatever, put the percentages on the bottom, that's what they're doing. They're seeing which one's more likely to happen. And then, of course, if we both have 4 of a kind, then there's this hierarchy with the numbers, right? We talked about like the aces, right, Clinton? Okay, so but if we're just comparing between hearts or between flushes and 4 of a kind, which is exactly the conversation he and I had, the 4 of a kind is less common, so that one would win.
Is a flush, does that have to be sequential?
No,
That's a straight.
that's a straight flush, yes, and there's straights as well. I'm not doing straights on here, but yes. We could talk about royal flush too, couldn't we? Yeah, we could. All right, we got one more, I think, right? 2 more, rather. All right, full house. Does anybody know what a full house is? It is a TV show in the 90s, yes. When we're watching it. So aside from the TV show, it's also a hand of poker. And Tyler told us it's 3 of one card and 2 of another. Okay? So the first thing we're going to do is going to look kind of like this last problem on on letter F. The first thing I have to do is I have to pick which value card it's going to be. So how many value cards are there? 13. There's 13 different values I could have. And I'm going to pick one of them, right? Okay, that's the card's value. Okay, that didn't actually pick me any cards. Once I pick the value of the card, I want to either pick 3 or 2 of them, and I don't care which one you do right now because you're going to do the other one in a minute. 3? Okay, so we're going to do 3C3. So again, what this did is this picked the value of the card. So this said, I'm going to pick kings. And then this one said, it's not 3 though. I messed that up. 4. Sorry about that. 4C3. There are 4 kings, and I want to pick 3 of them. Okay, does that make sense? So this gets me 3 of some card, some specific card. After that, I need another card. How many card choices do I have? That's how many card choices, how many value choices. I should word my statement better. How many different values do I still have? I have 12 left. All right, I already picked one of the values, and that was my 3 of a kind. I need to pick another value, and I have 12 other values left to pick from. So I need to pick one of those 12 value cards. And then how many of those cards do I need?
2.
I need 2. How many are there? There are 4 of them to pick from. Okay, so there's 2 pieces here. This gets me my 3 of a kind, and this gets me my 2 of a kind. Okay. The 13C1 says I have 13 choices of values to make. Once I have that value determined, I need, out of those 4 cards, I need 3. The 12C1 tells me I have 12 different values of cards left to choose from. Pick one of those 12, and then of the 4 cards of that value, I need 2 of them. Everybody with me? Now, some of these have the same sort of form that we've already seen. What was 13C1?
13.
That's 13. Now, 4C3 is not a values, we haven't talked about that pattern yet. So we're going to work it out. What's going to go on top? 4 factorial. On bottom? 3 factorial, 1 factorial. Okay, we're going to come back and finish that in a second. Okay, so let's just hold on to him tight. What's 12C1? That's 12. And then 4C2, we haven't worked out a pattern or anything for that either, so what should that look like?
4 factorial, 2 factorial.
Awesome. Okay, so I have 13 at the beginning. What is 4 factorial over 3 factorial? That's just 4, right? You can write down 4 times 3 factorial, and the 3 factorials cancel. I've got, this did not get a 1 in there. Okay, and then I've got a 12 here. How about 4 factorial over 2 factorial, 2 factorial? Well, what is it? No. Okay, so this would actually be 4 times 3 times 2 factorial. And I'm not going to end up with enough space down there to do this. I'll move it there in a second. Let me write this here, and then I'll move it. 4 times 3 times 2 factorial. It is 6. And there's a 2 factorial, and then I've got 2 times 1. Okay, the 2 factorials cancel, and then what else is going to cancel? 2 and the 4 to make it 2. So 2 times 3 is 6. That's pretty good. All right, so we've got 2, I've got a 3, I've got a 6. So I've got 13 times 4 times 12 times 2. What does that give me? So there are 3,744 full house hands in a deck of cards. So does a full house beat a flush? Yes, it does. The flush had 1,287. Is that what it was? Yes, it does. Just a second. It had 1,200. What was it?
87.
87, but that was just hearts. Times 4 to get me all of the flushes because I have 4 suits. Yeah. So there are a little over 4,000, right? Almost 5,000. Actually, a little over 5,000 because of the number. So somewhere around 5,000 flushes, and there are 3,744 full houses. So that's a less common arrangement of cards. Okay, we're going to do one more just because I want you to see that it doesn't matter what the stipulations are, you can work with it. This is a hand of 2 black cards, 2 diamonds, and a heart, and if you get this, fabulous, right? I mean, you're not doing any good, but we're going to calculate how many of these there are, and you'll see exactly why it doesn't matter. All right, so there's 3 pieces here of information. 2 black cards, second piece is the 2 diamonds, and the third piece is the heart. All right, so how do you get 2 black cards? 26, because there's 26 black cards. C2, because I want 2 of them. How do I get 2 diamonds? 13, this is all multiplied now, so multiplied by 13C2. And then how do I get a heart? 13C1. And the 13C1, and we know, is the number 13. The others, though, we don't have that feature, so I'm going to write them out. So the first one's 26 factorial over what? 2 factorial and 24 factorial. How about the 13C2? And the last one's 13. Good. All right, so 26 I'm going to write down to 24, right? 26 times 25 times 24 factorial over 2 times 1 times 24 factorial. Then we'll do the same with the 13. So 13 times 12 times 11 factorial over 2 times 1 times 11 factorial. And then I've got my 13 at the end. All right, so how about some reducing? What do you want to reduce? 2 and 26 to become 13. 24 and 24. What else? Let's just move to the middle one. 11 factorial and 11 factorial. 2 and 12 to become a 6. So the result is 13 times 25 times 13 times 6 times yet another 13 at the end. And how many of these are there? Is that one what you said, DJ? Does that look right? 550?
Yes.
All right. Okay, so the reason this isn't a very good hand of cards is because there's a lot of them. Agreed? Compared to the full house and the flush and the things like that, this is not a very uncommon hand. There's 329,000 of these guys. Okay, any question about this? All right.